Welcome to The Explainer. You know that feeling when you've just rolled out what you think is a totally brilliant idea at work? You cross your fingers, wait for the results, and then you're stuck wondering, did that actually work or was it literally just a fluke? It's a surprisingly common problem, right? In fact, companies are bleeding millions every single year just because they're relying on gut feelings instead of hard data. So today we're unpacking a really targeted curriculum that completely cures this core anxiety. We're going to look at the exact mechanics of statistical validation and show you how to definitively take the guesswork out of your decision-making. Okay, let's dive into this. The central thesis question taken directly from our source material is super simple, but honestly, it's pretty daunting. How do I know what works? Because let's face it, relying on your gut is basically just corporate gambling. Whether you're tweaking a website, changing up a product feature, or launching a whole new initiative, you need a definitive, measurable way to separate actual success from total random chance. And that is exactly what this curriculum tackles head-on. To answer that, the source gives us a really clear roadmap. We'll start with how to know it works, then hit the sample size equation, compare A/B testing versus full factorial, and finally wrap it all up with the practical case study. Now, what's really interesting about this slide is the deliberate sequence here. This isn't just some random list of topics, it's a carefully engineered journey. Think about it. You can't just jump into testing without knowing the math first, right? Otherwise, you're just generating bad data. This entire pipeline takes the learner from pure theory, introduces both basic and advanced testing, and then pushes them right into real-world application. So let's kick things off with part one, how to know what works. When you're staring down total uncertainty, the source gives us one unambiguous answer: statistic testing. It is not about intuition, and it's definitely not about asking a couple of coworkers what they think. It's about rigorous objectivity. I like to think of statistical testing as basically a lie detector test for your data. When you make a change, there are always a ton of different factors at play. Well, statistical testing is the overarching framework that filters out all that noisy random chance, so you can confidently spot the actual signal and know for sure if your idea made a tangible difference. Let's move to and see how this builds into part two, the sample size equation. The source literally kicks off the deep dive by stating, the participants would learn the sample size equation. And you might be wondering, why is this the absolute first thing taught? Well, think of it like this. If you flip a coin 3 times and get heads every time, you might falsely jump to the conclusion that the coin is totally rigged. But if you flip it 3,000 times, the actual truth reveals itself. The sample size equation is that essential piece of math that tells you exactly how much data you actually need to collect to eliminate that random chance. Test on too few subjects, and your results are completely meaningless. Test on too many, and you've just wasted a ton of precious time and resources. So this equation, it's the absolute bedrock of trustworthiness for everything that follows. Moving right along to part 3, A/B versus full factorial testing. And this brilliantly illustrates what we do once we actually have that sample size locked in. We need a testing methodology. On the left, we've got your classic A/B testing. This is your straightforward, isolated test. You change a checkout button from blue to red and just see what happens. But then on the right, the curriculum introduces full factorial differences. And this is where things get really advanced. Imagine changing the button color, the font size, and the price point, all at the exact same time. Full factorial testing lets you mathematically untangle that incredibly complex web so you can see exactly how all those different moving parts interact to impact user behavior. It's a real game changer. So the big takeaway here is that by mastering both of these methods, you make sure you aren't just a one-trick pony. You now have a precision scalpel for those simple, single-variable A/B tests and a heavy-duty diagnostic machine for those complex, multivariable environments. It gives you a fully robust analytical toolkit right after you've nailed down the foundational math. Which brings us to our final section, part 4, the practical case study. The source explicitly notes, finally, the participants would have a practical session. And honestly, this is the crucial climax of the whole learning experience. I mean, you can memorize equations and study methodologies all day long, but theory just evaporates without actual practice. The curriculum designers deeply understand this, which is exactly why they mandate this hands-on environment to force participants to grapple with the math themselves. So the crucial point is that this practical session takes the exact form of a case study. And why a case study specifically? Because textbook data is completely clean, but real-world data is messy. It's incomplete, and it's honestly pretty chaotic most of the time. The case study is the vehicle that drags those pristine sample size equations and A/B tests out of a sterile lab and drops them right into reality. It forces everyone to wade through the noise and prove they can actually execute when the stakes are high. So we've mapped out the exact mechanics of validation here. We started from the rigorous math of sample sizes, moved through specialized testing methodologies, and took it all the way to proving it in a messy, hands-on, practical case study. The roadmap is totally clear, and these tools are incredibly powerful. So the only thing left to ask as you look at your own projects, your own brilliant ideas, and your own leaps of faith is this: now, how will you know what works?